In these problems, we're dealing with something called piecewise functions. And a piecewise function is something where for part of the graph it's one thing, and for another part of the graph it's another thing. So you're sort of like sewing two halves of different animals together, and they come out looking kind of funny. Let's take a look at this one. It says f of x equals this thing, while it equals this thing when x is less than or equal to 1, and this thing when x is greater than 1. So on the half of the graph to the right of the line x equals 1, we're going to have this. And if we just look at this, negative 1/5 x plus 4/5, that's a regular linear equation. It's got a negative slope here, a negative 1/5. So it's going to look like a line that slopes gently down. Let's look at this half where x is less than or equal to 1. We've got a negative 1/5 x squared plus 2/5 x plus 2/5. This is a quadratic, and you should be able to recognize that. So you're going to have at least part of a parabola. And one thing you might remember about your quadratic equations is that when the coefficient of the x squared term is negative, it opens downward. So if we were to think about what's on the left half of a downward opening parabola, it would look something like this. So we would want to look for some combination of these two, and I'm guessing, you'd have that and then that, or maybe that. So let's look at these graphs and see what we've got. Over here you can see an upward opening part of a parabola, so that's not going to work for us, although it does have a nice gentle downsloping line there. Here we see another upward sloping parabola. That's not what we're looking for. They're also on the wrong sides of the graph. The parabola piece should be to the left of x equals 1, and the line should be to the right. Here in C, we've got the downward sloping line and a downward opening piece of a parabola, but again the order is reversed. And then finally in D, we've got the right shapes here. So here's our downward opening parabola, and then at x equals 1 it switches to that linear equation. So correct answer there is D. Let's look at another one. Now this might take a little review from some trig here. We've got this piecewise function where the top one is 6 over pi times x plus 7, and that's where x is less than negative pi over 2. And then after that, where x is greater than negative pi over 2, we have negative 4 sine x. So what's going on here? Well, don't get confused by this pi in the denominator. You can just think that's 3.14. So that's a number. So we really have just a linear equation here with a positive slope. 6 divided by 3.14, it's going to be a little bit less than 2. So it's an upward sloping line like that. And that should be on the left half of the graph, where x is less than or equal to negative pi over 2. And if you want to just convert pi over 2 in your head, well, pi is a little over 3, so this is a little, well, it's very close to 1.5. So negative 1.5, we're looking for, to the left of that, we're looking for an upward sloping line like that. Now, what about this piece, the negative 4 sine x? Well, the graph of sine is this sort of squiggle, okay? So after, to the right of negative pi over 2, we're going to look for a squiggle. And actually, with this much information, let's just see what we've got here. In A, we have a downward sloping line and then a squiggle, and we wanted an upward sloping line. In B, same thing, downward sloping line, a slightly different squiggle. Now C looks like it might be promising. We have an upward sloping line until right here, which looks like it's just about negative 1.5, which is about negative pi over 2, so that looks right. And then we have this squiggle coming afterwards, but is this squiggle negative 4 sine x? Because one of our choices is none of these. So how do we determine that? Well, you might want to look back at the unit circle for this and remember about sine. Remember, on the unit circle here, we're plugging in these values, 0, pi over 6, pi over 2, pi, etc. And we're getting out these coordinates, and the sine is the y coordinate. So the sine of 0 is 0. So that's one point to check. If we were to plug in 0 here for x, the sine of 0 would be 0. You'd have negative 4 times 0. That'd be 0. So the whole thing would come out to 0. So when we plug in a 0 for x, we get out a 0. So the point 0, 0 should be on this graph, and lo and behold, it is. But we ought to check one more. One good place to check is pi over 2. At pi over 2, the sign is 1. Now remember, pi over 2 on our graph, that's about 1.5. So our x-coordinate is going to be about 1.5. And our y-coordinate we're going to get by plugging in here. So the sign of pi over 2 is 1 times a -4. So that should be -4. So do we appear to have the point 1.5, -4 in here? And lo and behold, we do. So this checks out, and C is going to be your answer. So that's a little bit of work with piecewise functions.